Alright, so we just covered the two basic fundamentals when it comes to algebra. We have the linear equation and we have the quadratic equation. But there's many more different types of equations. Now here's a picture of the Ninja Turtles, and I'm sure you guys have seen these guys before. But anyways, their strength is that when they work together, they're the most successful. So each one has their own individual skill. Like Michelangelo has nunchucks, Leonardo he does like the katanas, and then this guy does the bow staff. That's Donatello, and Raphael has the scythe. So separate, they're a little bit weakened. Okay, now here's an image of Jackie Chan. And Jackie Chan, what's unique about him is that it doesn't matter which weapon is in his hands, he can use all of them. So understanding all the different types of functions and how they work is really being a master of the arts of mathematics. So we're going to continue on in our discussion on our functions. So here we have linear, exponential, quadratic, polynomial, rational, absolute, logarithmic, trigonometric, and radical. Okay, so first things first is we have to be able to identify what these functions look like. And one of the basic things is that you need to be able to see what's being done to the variable x. For example, here we have a linear equation. We know, like I said in some other videos, that if it's a degree of 1, so out of all of these, we see that the x is being taken the square root. This is x to the power of something. This is x in the exponential position. This is in a denominator. This is being squared. This is being logged. This one's the degree of 1. This is sine, cosine. So that's trig. This is absolute value. So we can see basically that's the clue. Whatever's being done to the variable, and then we come up with these different types of equations. Okay, so over here, each of these different equations all have graphs that go with them, and being able to understand how the graph will behave and all the different functions will really be helpful. So we're going to go ahead and take a look at this. So here's a little cheat sheet. This will be attached, and what I want you guys to do is basically see if you can make the connection with all of these on the slide. So let's go back. Linear equation has a degree of 1, so that would be C. Exponential is when the x is in the power position, so that would be G. Quadratic is when it's raised to the second power, so that's E. And then a polynomial is when we have it's to the power of a whole number, okay, so that's H. Rational is when it's in a fraction. Absolute value is when the x is being taken the absolute value of. Logarithmic, that's when it's a log. Trig is when it has trig functions going with the x. And then a radical, obviously, is when it has the radical. Okay, now let's look at the graphs. So a linear equation is a line, a straight line. So that's going to be f. Exponential is a curve, so it starts real small and then it starts to grow rapidly. That's exponential. Quadratic is a U-shaped graph called a parabola. A polynomial is typically like a roller coaster ride where it's continuous all the way through and it's still a function. That's polynomial. And then a rational function is typically when we have these asymptotes, and so you can't see it, but there's this barrier right here. We usually have a horizontal asymptote, not always, and then also a vertical asymptote. So that's a rational function. Absolute value kind of looks like a parabola, but it's two linear equations, kind of like this, two linear equations that go up. Oops. And so then that would be G. So a logarithmic is the inverse of an exponential. So if you were to flip it over the y equals x line, that's going to be h. And then a trig function is a curve, kind of like a sound wave. And then we have a radical function that starts at 0 and then goes on, because you can't have any negatives in a radical. So each of these different functions could have a domain of all real numbers where you can put in all x values, and some of them have restrictions where the domain is limited on what you can substitute. For example, the rational function, you can't have 0 in the denominator, so whatever values create a 0 in the denominator are going to be an issue. Okay, so looking at this, this is a great sheet to be able to identify the key features of all these different functions. So I'm going to just go through with a linear function. We'll have all of these, so you guys can take a look as you're taking notes here. Quadratic will have all of these characteristics. A cubic function will have all of these. Exponential, these, and rational would have all of those. Okay, so this is just a good information reference guide for you as you're going through your quest to understand the algebra part of this class. All right. So next what I'm going to talk about is translations. All of these functions can move when it comes to the graph. So depending on where an extra value is for any of those functions that we just talked about. So each of those functions, whatever's being done to the variable x, if you were to put an addition or a subtraction sign and then add a value to that function, that's going to shift the graph either up or down c amount of units, whatever that number is. Okay, so c if it's positive, and I'm sorry, up if it's positive and down if it's negative. Okay, now if that's on the inside of what makes that function the function, okay, so let's say if it's a radical, if it's underneath the radical with the x, then that's going to shift it left or right c units. Okay, so if it's left, it'll be positive. So if this is a plus sign, it's going to move to left, and then it's going to move to the right if it's negative. Okay, now if you're multiplying it by a number, that's going to stretch or shrink vertically by a factor of c. So if c is bigger than 1, so like 2, 3, 4, if it's bigger than 1, it's going to stretch an absolute value. So if it's negative, we'll talk about that later, but it'll still stretch it. And then it'll shrink or squat if it's in between 0 and 1, which means it's a fraction. Okay, if the number's on the inside, what that's going to do is stretch or shrink it horizontally, and we see that a lot with the trig functions by a factor of c. Okay, so so if it's a fraction, it's going to stretch, and then if it's bigger than 1, then it's going to shrink. Okay, if the negative's on the front, then that's going to reflect over the x-axis. We'll talk about that in a second. And then if it's on the inside, it's going to reflect over the y-axis. So I wanted to show you guys real quick on Desmos. Here we go. So here we have a quadratic. A quadratic is a parabola, and this is the parent function. Now if I was to, in the inside of the parentheses, subtract 2, that's going to shift the graph either up or down or left or right. Which one is it? Okay, well based upon that part of our PowerPoint, we see that if it's negative, it's going to move to the right. So we see that once I put that on, then we see that the parabola has shifted over 2 units to the right. So all the points, so starting with like say the vertex, it's moved over 2 units. Okay, so now if I put it on the outside of what makes that function the function, okay, that positive 2 is going to shift it up. If I made it negative 2, then that's going to shift it down. Okay, that's how these translations work. Now if it's in the front being multiplied by what makes the fraction, it's going to stretch. So imagine like a hair tie or something. If you pull on it, it's going to get skinnier and skinnier. So as this number gets bigger, do you see how it starts to stretch? Now if this is a fraction, let's put a fraction, 1/2, then it gets wider. And if I make that a little bit wider, see how it gets wider and wider, so the smaller the fraction, the wider it gets, the slower it grows. Okay, and then the negative, like I was saying before, it's going to reflect over the x-axis. So here is an absolute value function. Now if I put a negative 3, it's going to shift over to this side. But then if I put a negative on the inside, see if I put it on the outside, then it's going to reflect over the x-axis. But if I put it on the inside right next to the x right there, then it's going to reflect over the y. So watch this. So over the y, back, over the y, back, over the y, back. So each time it's negative, it reflects over the y-axis as opposed to the x-axis. Does that make sense? Great.